So this question from 1990 asks us to name the compound, the organic compound above. So what I'll do is I'll draw it out here so it is very clear. So this is CH3, C, CH2, CH3, double bond, CH, CH, then CH3, then is CH3. The first thing we do is to look for the longest chain of carbon. We look for the longest chain of carbon. So let's count from here. We have 1, 2, 3, 4, 5. Let's go again. 1, 2, 3, 4, 5. However, coming from this bottom, would have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. One thing we know is that the longest chain must cross this double bond here, And if you go from left to right, you just have 5 carbons, 1, 2, 3, 4, 5. Or from left to top, you have 1, 2, 3, 4, 5. But if you go from bottom here to left to right, or bottom to top, you have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, which is longer. So I would like to go from bottom, since it is longer, go from bottom right here to the right. So, and that can be considered as X. So we need to determine the location of the double bond. We have a double bond here. So we need to determine the location of that double bond. So it will be counting from bottom, we have 1, 2, 3. It's on the third carbon. But counting from right, we have 1, 2, 3. Also on the third carbon. So the double bond is not telling us where to count from. So right here, we can count from anywhere from now, for now. So that is X3 in. Now this CH3, which is methyl, is not part of this longest chain. So it's a substituent or a branch. It is also methyl. So it means there are 2 methyls in this compound. So we'll call it dimethyl. However, we must put the location of the methyl. Counting from from bottom to right, this methyl is on the third carbon, and this methyl will be 1, 2, 3, 4, 5 on the 5th carbon. But counting from right to bottom, this methyl should be on the 2nd carbon, 3rd, 4th, and this one should be on the 4th carbon. So we'll consider this as 35 and consider this as 24. It's clear that 24 is lower than 35. So it means we'll go from right down to bottom. So our name will be 2,4-dimethyl X3 in. 2,4-dimethyl X3 in, which is this right here in option C. In case you are still wondering, the reason why we are using the methyls to determine the position, instead of the double bond, is because the double bond is in the middle. And when a double bond is in the middle, you see, it does not tell us it's sitting in the middle. It does not tell us where to come from. So what will tell us what position to come from are the substituents that are bonded to the parent chain. Thank you.